Hello student, today now we'll start the new topics, that is the surds. We know that 5 is a rational number but root of 5 is not rational. The square root or the cube root of any real number is either a rational or irrational number. Similarly, nth root of any number is either rational or irrational. Now see this here, if n is an integer greater than 1 and if a is a positive real number and nth root of a is x, then it is written as x raised to n is equals to a or nth root of a is equals to x. Now see this the definition. If a is a positive rational number and nth root of a is x, and if x is an irrational number, then x is called the surd. Surd is an irrational roots. Now see this here. In a surd, nth root of a, the symbol, this is called the radical sign. N is the order of the surd and a is called the radicand. Now see this example. Let a is equals to 7, n is equals to 3. Then n cubic root of 7 is a surd because cubic root of 7 is an irrational number. Let a is equals to 27, n is equals to 3, which is called the order of the surd. That is, cubic root of 27 is not a surd because cubic root of, we know the cubic root of 27, that is equals to 3, and it is not irrational number and therefore it is not the surd. Which is not the surd? Cubic root of 27. Now next is a cubic root of 8, is also not surd. Now see this here, we know that the cubic root of 8 is 2, that is therefore it is not the, and the 2 is a rational number, therefore cubic root of 8 is not surd. Next, whether the fourth root of 8 is surd? Yes, the fourth root of 8 is surd. Therefore, fourth root of 8 is an irrational number and therefore the fourth root of 8 is called the surd. Now this year we are going to study the surd of order 2 only. Means that is the square root of 3, square root of 7, square root of 42, etc. The surds of order 2 is called quadratic surds. Now the simplest form of the surds. Now here first the root of 48. The root of 48 is equals to 16, root of 16 into 3. That is the root of 16 into root of 3. What is the root of 16? Is 4. 4 into root 3. Next is, this is the simplest form. That is root of 48 can be written as, that is a 4 root 3. Now next is a root of 98. Now this root of 98 can be written as, that is a 49 into 2. But 49 into root 2. What is the square root of 49? Is a 7. Therefore it is a 7 root 2. Now the numbers, that is a root 2, root 3, root 5. These type of surds are the simplest form which cannot be simplified further. Now next we'll see what are the similar surds. Which surds are called the similar surds or it is called the like surds. Now see this is the root 2, minus 3 root 2, 4 upon 5 root 2. Now if you see this, these are the some like surds. That is if p and q are the rational number and p root a, q root a are called the like surds. That is the two surds are said to be like surds if their order is equal and the radicand are equal. Now see this, in this case these two surds are equal. Their order is 2, here is order is 2, radicand is 2, radicand is 2. All these three surds are equal because their order is 2 and the radicand have the same number. Therefore these are the like surds. Now next, a root of 45 and root of 80 are the surds of the order 2. So their order is equals to the radicand are order is equal and the radicand are not the same. Now here is a 45, radicand is 45 and here is 80. Therefore these two surds are not same. Are these like surds? Let us simplify it as follows. Now the root of 45, it can be written as a root of 9 into 5. What is the root of 9? Is 3. And root of 5 is a prime number. Keep it as it is. Now next is root of 80. Now root of 80 can be written as root of 16 into 5. Now here is root of 16 is 4 and here is a root of 5. Now if we see this, the root of 45 is written as 3 root 5 and root of 80 is written as 4 root of 5. Now if we see this, these are the like surds because they have the same order, that is a 2, and the radicand is also same. Therefore, if we simplify and if we get their radicand and order both are same, then these two surds are called the like surds. Therefore, it means that these two are the similar surds or like surds. But before that, we have to simplify it. That is, their order and the radicand must be same. Now remember this, in a simplest form of surd, if order of the surds and the radicand are equal, the surds are similar or the like surds. This you have to remember. Now the comparison of the surds. Now see this here. This is 6 root 2 and here is a 5 root 2. Now when I want to compare this, now here if you see this, the order is same. Here is a 2 order, here is order 2. But the radicands are different. Then how we can combine them? That is 6 can be written as root of 36. That is same order. Here is order is same. That is a root of 36 into root of 2. What about here? 5 and here is a root of 5. Now again 5 can be written as root of 25 into root of 5. And now both of them have the same order. Therefore we can write in the same radicand, that is the root of 36 into 2, which is written as root of 72. What about here? That is a 25 into 5, which is a root of 125. Now in this case, the order is same, but the radicand 125 is greater than 72. Therefore, the second, 6 root 2 is less than 5 root of 5. Now the next example, that is 8 root 3 and 192. Now again here is the order is 2, that is we are learning, that is a surd of the order 2. Now these 8 can be written as root of 64 into root 3 and here is a 192. Again as the order is same, we can write in a same root, that is a 64 into 3, which is 192 and here is again 192. Now these two are equal, therefore 192 is equals to 192. That is the root of 192 is equals to 192. Therefore 8 root 3 is equals to a root of 192. Now the next is 7 root 2 and 5 root 3. Now to compare again here, the order is same and the radicand 2 and 3. These are the different. Therefore 7 can be written as root of 49. Here is a root of 2 as it is. 5 can be written as root of 25 and here is a root of 3. Now again here is we can write here 49 into 2, that is a 98, that is a root of 98, and again here 25 into 3, which is a 75, 98 and 75. Now in this case 98 is a greater than 75 and that's why 7 root 2 is a greater than 5 root 3. In this way we can compare the surds. Now the operations on the like surds, that is the mathematical operation, which is the addition, subtraction, multiplication, division can be done. Now in this case simplify these surds. If we see this here, that is a root 3 and the root 3, here is a root 3, that is the order is same and the radicand also same. Therefore we can add this, take the root 3 as a common, 7 plus 29, that is a 36 root 3. Now the next is 7 root 3 minus 29 root 3. Again take the root 3 as a common, 7 minus 29, you can get minus 22 root 3. Next is, that is a 13 root 8, 1 upon 2 root 8 minus 5 root 8. Now in this case we can take root of 8 as a common, 13 plus 1 upon 2 minus 5. And if we simplify it, then you will get that is a 26 plus 1 minus 10 upon 2 by taking the LCM into root of 8. That is, if we uh, find out their LCM, that is a 13 into 2, which is a 26 upon 2, 1 upon 2. Here is a 10 upon 2, and therefore it is a 26 plus 1 minus 10 upon 2 into root of 8. And if you simplify it, then you will get that is a 26 plus 1, which is a 27 minus 10. That is 17 upon 2 into root of 8. Now again, root of 8 can be written as that is a 4 into 2. Again, the square root of 4 is 2. That is a 2 root 2. And this is the simplified form. That is, this 2 get again cancel. And then you will get 17 root 2. Now see this again, the simplification of this third. That is 8 root 5. This 5 is a prime number. We cannot factorize it. Therefore, keep it as it is. Now here is a 20. Now 20 can be written as 4 into 5. And again 125. 125 can be written as 25 into 5. Now 8 root 5, keep it as it is. Here is as it is. Root of 4 is a 2 root of 5. Root of 25 is a 5 root of 5. Now again, all these are the like surds because the order is same, radicand is also same. Therefore, we can take root of 5 as the common, and in bracket you will get 8 plus 2 minus 5. 8 plus 2 is a 10. 10 minus 5 is again 5. And therefore, 5 root 5. This is the required answer. Now the next is multiply the surds. Here is a root of 7 into root of 42. Now this can be written as, that is, both of them have the same order. Therefore, we can write in a single radicand. That is a square root of 7 into 42. And it is written as a root of 7 into 7. 42 can be written as 7 into 6. Now again, 7 into 7, it's a square root. That is a 7 root 6. Therefore, next is divide the surds. That is a root of 125 upon a root of 5. Root of 125 upon root of 5, it can be written as in a single. Both of them have the same order. Therefore, we can write in a single square root sign. That is 125 upon 5. Therefore, root of 25, and the answer is 5. This is a rational number after simplification. Next is a root of 50 and a root of 18. It can be written as root of 25 into 2 into 9 into 2. Both of them have the same order. But to avoid this big multiplication, that is the root of 50 into 18. That is, we can factorize it in 25 into 2, 9 into 2. Square root of 25 is 5. 5 root 2 is here. 9 into 2. And the square root of 9 is again here is a 3. 5 into 3, which is 15. And again root 2 into root 2, that is 2. Therefore 15 into 2, which is the 30. And in this way we can multiply one surd by the another. Now next is a rationalization of surds. If the product of the two surds is a rational number, each surd is called a rationalizing factor of the other. Now here is if root 2 is multiplied by root 2, then root 2 into root 2, that is a root of 2 into 2, that is root of 4, and root of 4 is equals to 2, which is the rational number. Therefore, rationalizing factor of root 2 is root 2. Next is a multiply. That is a root of 2 into root of 8. Now this is again simple. Both of them have the same order, and it can be written as in a single radicand. That is a 2 into 8, which is 16, and root of 16, that is equals to 4, which is the rational number. Therefore, we say that the root 2 is a rationalizing factor of root 8. Similarly, 8 root 2 is also rationalizing factor of root 2, and in this way. Now see this here, the rationalizing factor of a given surd is not unique. If a surd is a rationalizing factor of a given surd, then a surd obtained by multiplying it with any non-zero rational number is also a rationalizing factor of the given surd. Now see this here, find the rationalizing factor of root of 27. Now the rationalizing factor of root of 27 is it root of 27? No. Now first of all, if we simplify root of 27, it can be written as root of 9 into 3. But find what is the square root of 9, which is a 3. That is a 3 root 3. Now if we multiplied 3 root 3 by only the root 3, then we get that is a 3 root 3 into root 3 is a 3, and 3 into 3 is 9, which is the rational number. Therefore root 3 is a rationalizing factor of root of 27. Therefore we want to simplify this, write in the simplest form. Now next is rationalize the denominator. Now to the denominator there is 1 upon root of 5. Therefore to rationalize the denominator, we will multiply to the numerator and the denominator, that is a root of 5. 1 into root of 5 is a root of 5. Root of 5 into root of 5 is 5, and therefore this is a root of 5 upon 5. As here is a denominator is a rationalized. Now rationalize again here the denominator. Now to rationalize the denominator, what is the irrational number here? Irrational number is a root 7. Therefore in this case we will multiply the numerator and the denominator by the root of 7 only, and not 2 root of 7. Therefore that is a 3 root 7, and 2 root of 7 into root of 7, it will become again 7, and therefore 2 into 7, that is a 14. Therefore 3 root of 7 upon 14, and in this way the denominator is rationalized. We can make use of the rationalizing factor to rationalize the denominator. It is easy to use the numbers with a rational denominator. That is why we can rationalize it. Now we'll see the exercise 2.3. Now the practice set 2.3. State the order of the given surd given below. Cubic root of 7, here is the order is 3. 5 root 12, that is here is the order is 2. 4th root of 10, order is 4. And square root of 39, the order is 2. Cubic root of 18, order is 3. Now next is state which of the following are surds and justify your answer. Now this is the definition of the surd, that is if a is a positive rational number and nth root of a is x, where x is an irrational number. This is important. X is an irrational number, then that is the here is the nth root of a is called a surd. This is the, and this symbol is called the radical sign, that we have learned here. That is, this is the order is 3, order is 2, order is 4, order is 2, and order is 3 for these surds. Now state which of the following are surd and justify your answer. If a is a positive number. Now see this here, the cubic root of 51. Now we'll check one by one. Here is a radicand which is we treat as a is equals to 51, which is a positive rational number. N is equals to, that is 3, which is a natural number. And cubic root of 51, the whole number is irrational number. Therefore the cubic root of 51 is surd. Next is a 4th root of 16. Here nth root of a is equals to 16, which is a positive natural number. It's a correct one. N is equals to 4, natural number. But what is the 4th root of 16? The 4th root of 16 can be written. Here is a 4th, and 4th root of 2 raised to 4. 16 means what? 2 raised to 4. Now here is a 2 raised to 4, and whole bracket is to 1 by 4, and it comes to be 2. That is these 4 get cancelled. Power to the power, that is a multiplication of the power, that is a 4 into 1 by 4. That is equals to 2, and it is a rational number. That is the last condition is not satisfied. We require here the irrational number, and therefore 4th root of 16 is not surd. Now next is a 5th root of 81. That is nth root of a. That is the 5th root of 81. Here is a is equals to 81, which is the positive rational number. N is equals to 5. That is a natural number. Therefore 5th root of 81 is irrational number. This is the irrational number, and therefore The fifth root of 81 is a surd. Now the square root of 256. Here the radicand is a, which is the positive rational number, and the order is 2. It's a natural number, is correct one. But what is the square root of 256? That is equals to 16, which is not the rational number, and third condition is not satisfied. Therefore, root of 256 is not surd. And the next is a cubic root of 64. Again, here is the nth root of a. Here is a is equals to 64, which is the positive rational number. N is equals to 3, that is a natural number, that is order. And cubic root of 64, that is equals to 4, is the rational number. And which is not irrational number, therefore third condition is again not satisfied. Therefore the cubic root of 64 is not surd. Now in this case that is the square root of 22 upon 7. Now here is the nth root of a is equals to root of 22 upon 7. A is equals to 22 upon 7, n is equals to 2, order is 2. Here is a is a positive rational number, n is equals to 2, which is the natural number, and this square root of 22 upon 7 is an irrational number. Therefore, this total is called a surd. Now, next we will classify the given pairs of the surd into like surd and the unlike surds. Now, see this here. The order is same here. Again, can we simplify this? Yes, we can simplify it. That is the root of 52 can be written as 13 into 4. Now, what is the square root of 4? Which is 2. And it is written as root of 52 is equals to 2 root of 13. And next is a 5 root of 13. Here is a 5 root of 13. Now here is the order is same. Radicand is also same. Therefore 2 root of 13 and the 5 root of 13. These are the like surd. It means that is the, if we simplify root of 52 and 5 root of 13. These are the like surds. Now the next is a root of 68. Here is the root of 68 and 5 root 3. Now the root of 68 can be written as 17 into 4. And here is a 5 root 3. Keep it as it is because 3 is a prime number. We cannot factorize it. But the 68 can be factorized like this, 17 into 4. Now what is the square root of 4, which is 2? The here is, that is a 2 root of 17 and 5 root 3. Now in this case, order is same, but the radicand is different. Therefore, the surds are unlike surds, and they are, though they have the same order, but the radicands are the different. Next question is 4 root of 18. Now the root of 18 can be written as 9 into 2. And what is the square root of 9? Which is 3. That is a 4 into 3, which is a 12. 12 root 2. And here is a 7 root 2. The root 2 is a prime number. We cannot factorize. Now in this case, the order is same. Radicand is also same. Therefore, these are the like surds. Now the next is 19 root of 12 and 6 root of 3. Again, root of 3 is, that is a root 3 is a prime number. We cannot factorize it. Therefore, keep this as it is. Now root of 12. The 12 is a composite number. We can factorize it like this, 4 into 3. What is the square root of 4? That is 2. Therefore, 19 into 2 root 3 and 6 root 3. 19 into 2, that is a 38 root 3 and 6 root 3. And these are the like surds because they have the same order and the same radicand is present there. Now next problem is 5 root of 22 and 7 root of 33. 5 root of 22 and 7 root of 33. The order is same, but the radicand is different. If we try for its a factorization, here is a 11 into 2 and here is a 11 into 3. Still, we cannot have the same radicand. Therefore, these two are the unlike surds. Now next question is 5 root of 5 and the root of 75. Now here is a 5 root of 5. Root of 75. 5 is a prime number. We cannot factorize it, but the 75 can be factorized like this, 25 into 3. But what is the square root of 25? Is 5. 5 root 3. And here is a 5 root of 5. Again the order is same, but the radicand is different. Here is a 5 and here is a 3. Therefore, these two surds are called the unlike surd, though they have the same order. Now next is simplify the following surds. That is the root of 27. Now root of 27 can be written as 9 into 3. What is the square root of 9? The square root of 9 is 3. Therefore 3 root 3. Therefore this is the simplification. That is the root of 27 is equals to 3 root 3. Root of 50. Now root of 50 it again can be written as it's a composite number 25 into 2. Therefore what is the square root of 25? It is a 5. 5 root 2. Therefore root of 50 is equals to 5 root 2. Root of 250. Root of 250 again can be written as 25 into 10. Therefore, what is the square root of 25? Is 5 into root of 10. Always we express that number, that is the product of the two numbers, such that one is the square of the any other number, and we can factorize it. This is the proper simplification or expressed in the simplest form. Therefore, root of 250 can be written as is equals to 5 root of 10. Now next is a root of 112, that is 112. It can be written as 16 into 7. But what is the square root of 16? Is 4. It's a 4 root of 7. Therefore, root of 112 is equals to 4 root of 7. Next is root of 168. You must know all the tables from the 21 or 11 to 30. Then you can factorize it fastly. That is the root of 168 can be written as 4 into 42. Again, what is the square root of 4? That is a 2. Therefore, it is a 2 root of 42. That is a root of 168 is equals to 2 root of 42. This is the simplest form of root of 168. Now, we'll compare here. Compare the following pairs of the surds. Here is a 7 root 2 and 5 root 3. Now, order of the surd is 2. Therefore, we will take this 7. In the radicand sign, it will become 7 raised to 2. Here is a 5. Again, order is 2. 5 raised to 2. 49 into 2. 25 into 3. Therefore, 49 into 2 means 98. 25 into 3 means what? 75. Now, in this case, 98 is greater than 75. But the 98 is for which number? 7 root 2. And therefore, 7 root 2 is greater than 5 root 3. Now, the next is a root of 247 and the root of 274. Now in this case the order is same, and these two surds do not have any multiplicative factor before the surd term, and therefore that is a 274 is greater than 247. Therefore root of 247 is less than root of 274. Now next is 2 root 7 and the root of 28. Now here is a 2 root 7 and the root of 28. Now 7 is a prime number here is a, and the order is here is a 2. Therefore here is in the same radicand sign, that is a 2 raised to 2 into 7. And here is a root of 28, keep it as it is. 2 raised to 2, that is a 4. 4 into 7, that is a 28. And here is a 28. Both are same. Therefore 2 root of 7 is equals to root of 28. Now next is 5 root 5, 7 root 2. Now again this 5 can be written as a root of 5 square into 5. And 7 root 2 can be written as 7 raised to 2 into 2. Here is a 25 into 5. 7 raised to 2 means 49 into 2. Here is a 125. Here is a 98. 125 is greater than root of 98. But 125 is for 5 root 5. Therefore 5 root 5 is greater than 7 root 2. Now the next is 4 root of 42 and 9 root 2. Now in this case 4 root of 42 and 9 root 2. Again here is a root of 4 square into 42 and the root of 9 square into 2. 4 square means 16 into 42. 9 square means 81 into 2. Here is a 672 is greater than 162. And that's why 4 root of 42 is greater than 9 root 2. Now the next number is 5 root 3 and here is a 9. Therefore 5 root 3. This can be written as, that is a root of 5 square into 3. Now again 9 can be written as in the root form as root of 9 square. But what is a 9 square? Is 81. Therefore here is a root of 25 into 3, which is 75. And here is a root of 81. Root of 81 is a greater one. Therefore root of 75 is a less than a root of 81. And therefore root of 81 is a for 9. Therefore 5 root 3 is less than 9. In this way we have compared these two surds. Now the next question is 7 to root of 5. Again the same type of question. Again 7 can be written as a root of 7 square. And this 2 root 5 can be written as root of 2 square into 5. Now 2 square means what? 4. 4 into 5, which is a 20. And is a root of 49. Root of 49 is greater than root of 20. But root of 49 is for the 7. Therefore 7 is greater than 2 root 5. Now the question number 6. Simplify. Now this is very simple. That is 5 root 3 plus 8 root 3. 5 plus both these two are the like surds. Same order, which is 2. Radicand is same, which is 3. Therefore 5 plus 3, that is a 13 root 3. Now next is, in this case we have to simplify it, and then we will make their addition and the subtraction. That is, here is a 9 root of 5 and is a 4 root 5. That is a 9 root 5 minus 4 root 5 is a 5 root 5. But what about the root of 125? We can simplify it right in the simplest form. That is 25 into 5. What is the square root of 25? Is 5. 5 root 5. 5 root 5 plus 5 root 5, which is the 10 root 5. And this is the simplest form, or it is a simplified form. Now next, third is 7 root of 48 minus root of 27 minus root 3. Now in this case, that is a 48 can be written as 16 into 3. 27 can be written as 9 into 3 minus root 3. Here is a root of 16, which is 4 root 3. Root of 9 is a 3 root 3 minus root 3. Now 7 into 4, that is a 28 minus 3 root 3 minus root 3. And if you take the root 3 as a common, then you will get 28 minus 3 minus 1. That is a 24 into root 3, and this is the simplest form for this third. The answer is 24 root 3. Now the next is root of 7 minus 3 by 5 root 7 plus 2 root of 7. Now in this case again we have the root of 7, root of 7, root of 7. We'll take the root of 7 as a common. Then what is the remaining here? Here is a 1 minus 3 by 5 and here is a 2. Now we'll simplify, add this, that is a 1 plus 2, that is a 3. Again here is a simplification. Let us make the LCM, multiply this by the 5. Then you will get 15 minus 3 upon 5. 15 minus 3 upon 5 into root of 7. That is a 12 upon 5 into root of 7. That is a 12 upon 5 root of 7. Now the question number 7. Multiply and write the answer in the simplest form. Here is a 3 root of 12 into root of 18. 3 root of 12, that is the root of 12 can be written as 4 into 3. Root of 18 can be written as 9 into 2. 4 into 3, that is the square root of 4 is 2. It is a 2 root 3. Square root of 9 is 3 root 2. Now here is a 3 into 2, 6. 6 into 3, 18. 18 into root 3 into root 2. What overall you will get? That is 18 into root of 3 into 2. Root of 3 into 2 is 6. That is 18 root 6. Now we can multiply these two types of the surds. Both of them have the same order and they can be written in the same radicand sign. That is a 3 into 2. That is equals to 6. Therefore 18 root 6. Now the next is 3 root 12 and 7 root of 15. Again can be 3 root 12 and the 7 root of 15. That is the root of 12 can be written as 4 into 3. What is the square root of 4? It is a 2. Therefore 2 into, here is a 3 into root of 3. Again here is a 7. That is a 2 into 3, 6. 6 into 7, which is 42. It is written as here. Now again here is a root 3 into root of 15. Again these two have the same order, and therefore we can multiply their radicand and keep in the same order, that is in the square root. Therefore 3 into 15, that is equals to 45. Therefore 42 into root of 45. Now root of 45 can be written as 9 into 5. What is the square root of 9? It is a 3. 42 into 3 into root of 5. But 42 into 3 means what? 126 root of 5. Therefore the answer, simplified answer is 125 root of 5. Now you can see this also here. These are the steps. Now the next question. See this here. That is a 3 root 8 into root of 5. That is a 3 root 8 into root of 5. Root 8 can be written as 4 into 2. What is the square root of 4? It is 2. It is written as 2 root 2 into root of 5. Now 3 into 2 is a 6. Root 2 into root 5. Now they can be written in, both of them have the same order. They can be written in the same radicand sign. That is the root of 2 into 5, which is 10. That is a 6 root of 10. Therefore it is a simplified form is a 6 root of 10. This is the simplified form. You can write this. Now the next question is, that is a 5 root 8 into 2 root of 8. Again here is a root of 8 into root of 8, that is 8. Therefore 5 into 2, that is a 10. Root 8 into root 8, that is 8. 8 into 10, which is 80, and 80 is the answer. Now the next question is, divide and the write answer in the simplest form. Root of 98 upon root 2. Now here is a root of 98 upon root 2. Both of them have the same order, therefore it can be written as, or root of 98 can be written as 49 into 2. What is the square root of 49? Is 7. 7 root 2 upon root 2. This root 2 get cancelled. You will get the answer as a 7. Now next question. Here is a root of 125 upon root of 50. Root of 125 can be written as, that is a 25 into 5. And root of 50 can be written as root of 25 into 2. What is the root of 25? Is a 5. In denominator root of 25, again 5. 5 upon 5 is get cancelled. And then in this case, you will get in the radicand root of 5 divided by root of 2. And they can be written as in the same radicand sign, that is the root of 5 upon 2. And this is the simplified form. Next, third one is root of 54 upon root of 27. Root of 54 upon root of 27 can be written as root of 54 upon root of 27. That is the root of 54 upon root of 27. Now we can divide this, then you will get, that is a 2. 54 upon 27, that is a 2, which is root of 2, and hence root 2 is the simplified form. Now next is in root of 310 upon root of 5. Again this can be written as, both of them have the same order, therefore we can write in root of 310 upon 5. You can divide, then you will get the division, that is the root of 62, and therefore root of 62 is the simplified form. You can divide this with the help of the 5. Now the last question is rationalize the denominator. Now in the denominator you have the root of 5, therefore multiplied n and d by root of 5. That is a 3 upon root of 5 multiplied n and d by root of 5. That is the 3 root of 5. Root 5 into root 5 is 5. And therefore the denominator root of 5 is a rationalized, which is 5. And therefore 3 root 5 upon 5. This is the answer. That is the denominator is rationalized. Now next is 1 upon root of 14. Now multiplied n and d by root of 14. Now in this case 1 upon root of 14 is equals to 1 into root of 14 upon root of 14 into root of 14. Root of 14 into root of 14 is a 14, Again the denominator is rationalized, and therefore the final answer is root of 14 upon 14. This is the answer. Now the next is 5 upon root of 7. Now multiplied n and d by root of 7. Multiplied n and d by root of 7. 5 root 7 upon root 7 into root 7. What is the root 7 into root 7? That is a 7. Therefore 5 root 7 upon 7. And we get the answer, that is a 5 upon 7 into root of 7. Now the next is 6 upon 9 root 3. Now what is again here is a irrational number. Irrational number is a root 3. Therefore we will multiply only numerator and the denominator by the root 3. Therefore multiplied n and d by root 3, that is 6 upon 9 root 3. That is a 6 into root 3 upon 9 root 3 into root 3. Now here is a root 3 into root 3, that is a 3. Now simplify this, 3 ones are 3. That is here is a 2. That is a 2 root 3 upon 9, and therefore 2 root 3 upon 9. This is the, that is the denominator here is a rationalized. Now the next question is, that is 11 upon root 3. This is again very simple. Now multiplied n and d by root of 3. That is 11 upon root of 3 is equals to 11 into root 3. Root 3 into root 3, and root 3 into root 3 is a 3. 11 root 3 upon 3. And that's why you will get, that is 11 root 3 upon 3. This is the number where the denominator is rationalized. And in this way we have completed the practice set 2.3. Now we'll see in the next video. Till then, goodbye.